Welcome to freehighschooleducation.com. Today we are going to do chapter 5.4. It's an exercise session, page 183. We start with number 22. Graph the solution set. Minus 5 is less than or equal to x less than or equal to 0. We will graph this 0, minus 5, and x is in between. And since we have equal and equal here, we will have solid dots on these two regions. You are supposed to try a value for x outside the accepted region, like here 1 and 2, and see if it fits. And this region is also outside, like minus 10, and see if it fits. And then you try one value inside the solution set and see if it fits. And this way we make sure that our answer is correct. Next is number 24, 7 less than t less than 7. Here it's better to split this into two inequalities. So we have here one is t more than 7, and the other one, and we have to put and, t is less than 7. And this is a conjunction. So we have to get a number that satisfies both conditions. So let's see if we can do this. We will plot these two inequalities. So the first one is, if 7 is here, open circle, more than 7. The second one is less than 7. This is an open circle. And this will be the region. Here we have the negative numbers, so let's put minus 7. We can see in this case that there is no number that's common to both inequalities, both solution sets of these inequalities. So there is really no solution for this conjunction, and the solution will be a null set. So our final answer is a null set solution for this, and this is the graph of null set. We do not do anything. You can see here that if there was something like this, then our only solution would be 7. You can tell from the beginning that this is going to be a null set. You cannot have a number that's less than 7 and more than 7 at the same time. So we can tell right away that this is going to be a null set. Then we go to number 26, x less than or equal to 4. And x less than minus 2. Here again we plot each one alone, and we have to have the common values between these two solution sets, and the common values are going to be our accepted final answer. So let's go here 0, 4, and this is equal to, so there's a solid dot here, less than 4. We are not going to number this number line 1, 2, 3, and so on, since you already know about it. And this is less than or equal to 4. The second one less than minus 2, so we can start our 0 here, 2, and minus 2, and open circle. You can see that this set lies within the bigger set, which is this one. Here is minus 2. So the final answer for this conjunction is this. Open circle here. And this will be the answer for this conjunction. Next is number 28, 5 plus x more than 6. And so this is another conjunction. 3x plus 5 more than 20. We solve each one alone. We take the 5 to the other side, so we get x more than 6 minus 5, and so x is more than 1. Here, 3x, we take 5 to the other side, more than 20 minus 5, and we get 3x more than 15, and x more than 5. Dividing both sides by 3. Now let's graph each one, and we are going to get the common values, and these are going to be the answer to this conjunction. So since here we are dealing with positive numbers, this is 0, 1, and we are going to do this on the same graph, 5. More than 1, open circle, and this would be the graph of x more than 1. More than 5, open circle, and this would be the graph of more than 5. Again, in this case, you can see that this graph lies within the this set here, and so our final answer, which is the common overlapping numbers between the two sets, will be from 5 on, excluding 5. So 5 is here. That will be the answer to this conjunction. Next is number 30, minus 3x more than minus 27. Or 2x minus 8 more than 6. Here or means that both values will be acceptable. So let's see what we get. We have to divide here both sides by minus 3. And recall that when we divide by a minus number, we change the inequality sign. So that will be x less than minus 27 divided by minus 3, and that will be a positive 9. Here we have to solve this. We take the 8 to the other side, and 2x is more than 14, and x is more than 7. So here we have two conditions, x less than 9 and x more than 7. And in the first instance, 0. And in the second instance, x is less than 9. So here is 9, here is an open circle, and here is an open circle. And in this case, here is 9, and this is the graph of x less than 9. And as you can see, these two sets cover all the numbers on the number line. So our final answer for this is the whole number line. Any value you take here is going to be either less than 9 or more than 7. Next is number 32, minus 3 less than or equal to 2x minus 5 less than 1. Here we have to break this into two inequalities. The first one is minus 3 less than or equal to 2x minus 5. And let's solve this. We take the 5 to this side, so we get 5 minus 3 less than or equal to 2x. And here 2 less than or equal to 2x. We divide by 2 both sides, and we get 1 less than or equal to x, which means x more than or equal to 1. So this is our first inequality. The second one here, this is a conjunction, and 2x minus 5 less than 1. 2x less than, we take the 5 to the other side, add it to the 1, that's 6. 2x, x, we divide by 2, and x will be less than 3. Here we have to graph each of these. So our first graph is this, and then our second is this, 6 and less than 3. So now zero, 1, and so on. Let's go to 3. We have a solid dot on 1. More than 1, it goes all the way this way. Less than 3, open circle, all the way this way. And now the common region, this is and, it's a conjunction. The common region is between these two numbers. And so our solution will be x is less than 3, more than or equal to 1. And this is the graph of this inequality. Let's put it properly. 0, 1, 3, open circle, closed circle. Again here we try a number from outside the region, like 0, and we see if it makes this a false statement. So let's try 0. Putting 0 here will give us minus 5. Minus 5 is less than 1, that's correct. But minus 5 is not more than minus 3. So that's false. So this is an unacceptable value. We try another value here, such as 10. It's an easy value. You can try it here. And then we try a value in this region. The easiest value to try in this region is 2. So let's see what 2 is going to give us. Minus 3, less than or equal to 2 times 2, that's 4. Minus 5, less than 1. Minus 3, less than or equal to minus 1, less than 1. minus 1 is more than minus 3, and minus 1 is less than 1. So the value 2 here in our acceptable region gives a true statement for this conjunction. And so we know that our work is correct. And with this, we come to the end of this session. We hope to see you again.